Today we'll look at the experiment for AND, OR and NOT gate and NAND gate. So we'll start with the basic connections for AND, OR and NOT gate. So one thing that we should remember before we start is that any voltage which is above 3 volt, we take it as 1, and any voltage which is below 3 volt, we take it as 0, like the input and the output. High is 1, low is 0. So now we'll start with the connections for AND gate. So this is the apparatus. So if we look at the diagram, we can see that this point at the resistance V, which is positive 5 volt, is connected to the positive 5 volt here, which is the power supply. So we'll make that connection, and then we will connect the output, which is here, to positive dVm, and then we'll connect A to A, and we'll connect B to B, and we still have to connect negative dVm, which will go from this to the ground. So we are done with the connections for AND gate. Now now we can check the output from here. So when the LED is on, it's 1. When it's off, it's 0. Now AND gate means we are you can say basic multiplication. So if both are 0, we'll get 0, or either one is 0, we get 0. We get only high when both are 1. So we'll just follow the table. So if both are 0, we see the voltage is 0.6, and we note that down. Now we'll make B as 1. You can see it's on. 0.7 here, we see the voltage is 0.7. Now change B to 0, A to 1, we get 0.7 again. We note it down. Now we make both 1, we get a high voltage, 4.9. Can stop. Okay, so now next connection is for the OR gate. Okay, so we'll connect the output to positive dVm. We'll connect A to A. We'll connect B to B. We'll connect 0 volt to ground, and again negative dVm to ground. Now let's switch it on. So for OR gate, it's like addition. So when you add both, you get 0 here, plus 1, plus 1. This will be 1 again. Okay, so if both are 0, you say it's 0. Now if B is 1, your voltage is 4.2, again high. Now if your A is 1, 4.2 again, it's high. And if both are 1, you can see both are 1, you get 4.2 again. So you note it down. Now the next one is the NOT gate here. So the connections are plus 5 volt goes to high. So the next is for NOT gate. So we'll connect plus 5 to 5. We'll connect 0 to 0. We'll connect A, since we have only one input, to A. We'll connect output to positive dVm, and we'll connect negative dVm to ground again. Okay. And now we'll connect it. Make sure that the wires aren't loose. So yeah, since this is NOT gate, whatever input we give, we get the complement of the output, like the opposite of the output. So here you can see that A is at 0, but we are getting a high voltage, so we write it down 4.9, because 0, our output is 1, which is the complement of the input. Now again, if we switch it to 1, we get 0 voltage. 1 complement is 0, so 0.1. So that's all for just AND, NOT, OR and NOT gate. Okay, now next is we are going to combine or make combinations in NAND gate to get NOT gate, OR gate and AND gate. Okay, so this is our practice now. So we'll make connections for NOT gate first. Yeah, so for NOT gate, we can see that 1 and 2 combined is giving us 1 input A, and here 3, which is our 1 output again. So we'll make the connections. So we connect 1 and 2 first, and 1 and 2 are internally connected. So we connect A to any one of them that's connected to 2. Now we try and we connect 3 to the output here, which is the LED display. Now we also have to connect 14 to high, and we have to connect so we connected 14 to high, we'll connect 7 to low. Okay, now we'll make the multimeter connections to note down the voltage. So we connect the negative of the multimeter to low here, and we connect the positive of the multimeter to the display. Okay. Now we'll take the readings. So when A is 0 here, you can see we get output in the multimeter as 4.87. You can note it down. Since it's NOT gate, we get the opposite output. Now when we switch on A to 1, you can see the voltage is low, 0.09 almost. Again, you can note it down. That's all for this part. Now next is for OR gate. So the connections are pretty simple, just follow the diagram. So we connect 1 and 2 again, and then we connect A to 2. Fine. Now we connect 4 to 5, and then you connect 5 to B. Okay. Now we connect 3, you can connect it from here, 3 to 9, and 6 here to 10. Now you connect 8 to the display, and you get here L1 point. All left is now 7 to low and 14 to high. Now we just have to make the multimeter connections. Okay, now the multimeter connections, negative goes to low, the positive goes to the display. Okay, we're done. Now we'll start. You can see both A and B are 0, and our reading is almost 0, 0.15. You can note it down. And now we take A as 1. We get reading as 4.92. Note it down again. Now we take B as 1, 4.91 again. Now we make both reading again. Yeah, that's all for this. Do it for AND gate. So we connect A to 1, we connect B to 2, and then we'll connect 4 to 5, and we connect 6 to CA, and we connect 3 to 5. Then we connect 7 to low and 14 to high. We connect the negative of the multimeter to low, and we connect the positive to CA. Now we'll switch it on. Both are 0 now, you see. So we get almost 0 as the output. Now we'll make B as 1. Again, the output is almost 0. Now we'll make B as 0, A as 1. Again, it's almost 0. Now we'll make both 1. Output is 4.91. We just note it down. That's all for this experiment. Thank you.